So this is Unit 6B, and the first question asks about range. Now you can find the information on range on page 383, but to find range, you just find the difference between the lowest value of the data and the highest. So the low value is 15, and the highest value is 52, and the difference of those two is 37, so our answer is C. For 2, when you go ahead and find the difference between the largest value and the smallest value, you will come up with the difference of $14.05, and that again is C. Now for 3, we're asked to obtain the 5-number summary. And you can find that information on pages 383 to 385. And when you do that, your question is going to be, well, how do I find the low value, the lower quartile, the median, the upper quartile, and the high? Well, what you do is this. The lowest value in the data is the low. The largest value in the data is the high. The median, you already know how to compute that. You arrange your data in ascending order and pick off the median. The lower quartile is the median for all the data values below the median. The upper quartile is the median for all the values, data values above the median. In this case, for 3, the low is 5.1, the lower quartile is 4.10, the median is 22.5, the upper quartile is 31.15, and the high is 51.7. And that is answer C. So for 4, when you go ahead and construct the box plot, our answer is C, because our median, when we use this data, compute the median, is 69.5. The lower quartile is 56, and the upper quartile is 80. The low is 32, and the high is 99. Then, the issue is, well, why do you choose C over B? Well, here's why. Because if you were to graph the data values on a number line, then the 56 is 24 units above 32. If you notice for B, this is supposed to be a difference of 24 from 32 to 56, and there's only supposed to be a 19-point difference from 80 to 99. Well, why is this space so large and this interval so short? It's inappropriate if we were to arrange our box plot on a number line with uniform distance between each point. So that's why we chose C. Now, for number 4, I beg your pardon, we just did 4. For 5, we had to do another box plot, and they give you choices, and when you compute the medians and the lower quartile, the upper quartile, and so on, you're going to come up with a C is the appropriate box plot. For 6, it says draw one box plot to illustrate bell-shaped data, another for uniform data, and a third for skewed data. Which of these shapes matches the box plot for the first 100 digits of pi? Well, I drew those. If we were given a bell-shaped curve and we drew a corresponding box plot, this is what we'd have. if we have, and notice the whiskers are long and the box is short compared to the whiskers, but it's uniform, it's symmetric. The uniform data, we've got symmetry, but the whiskers and the distance from the low to the lower quartile is the same as the distance from the lower quartile to the median, and from the median to the upper quartile, and the upper quartile to the high. So whiskers are shorter, we've got symmetry, and that's for uniform data. For skewed data, we're going to have the bulk of our data values to the right or left, depending on whether you're left skewed or right skewed. I'm left skewed here, and you're going to have one long whisker going to the left because I've drawn an example of a left skewed box plot. And by the way, the data they're talking about would be uniform for question 6. So for 7, we're talking about standard deviation. And you can, that's defined in terms not using symbols as I've used them on pages, if you look at pages 385 to 386, you'll find the definition of standard deviation. And x bar means the mean, x sub I means a data value for every different I value, I, 1, 2, 3, or 4. The data value will change. So the variation is the difference between the mean and whatever data value you choose, and you square that difference. And the standard deviation, sigma, is the symbol for standard deviation. N represents the total number of data values. So in symbol notation, sigma equals the square root of the summation. By the way, this summation symbol is sigma, and that's sum of whatever from 1 to n. So summation of the variance divided by n minus 1. If there's 10 data values, then 10 minus 1 would be 9, for example. So you plug in your values and compute your standard deviation. And please look at the information on page 385 and 386. And by the way, the appropriate standard deviation is B, choice B, which is 5.9. So now for 8, we have to use the range rule of thumb to approximate the standard deviation. And if you'll go to page 387, you will see that, and it makes for a very easy compute. Now let's do number 9. You are late for work. You have 2 options for getting to work. You may take the bus, which takes on average 40 minutes with a standard deviation of 12 minutes, or you can cycle, which takes on average 50 minutes with a standard deviation of 2 minutes. Compare these 2 distributions. You leave home, and so comparing the 2, taking the bus is faster on average, but there's more variation in times. Cycling takes longer on average, but there is less variation in times. Next, you leave your house at 8:20 and are supposed to start work at 9. Which option would you choose if you will be fired if you are even a few minutes late? Which option would you choose if you know that up to 15 minutes late is okay, but after that there is trouble. Explain your thinking. So I'll leave you to do that. So for number 10, the question is, can a sample variance ever be negative, a negative number? If so, for what types of data? If not, why not? Can the sample variance ever be 0? If so, for what types of data? If not, why not? Explain your reasoning. Well, here's the answer. The variance can never be negative, since the number is the sum of squared terms. You've seen that in the standard deviation, each of which must be positive or 0. It can be 0 only if all observations are identical. In other words, if every observation was, for example, 5, 5, 5, 5, 5. But in which case, all deviations from the mean would be 0. And we're done.